Hello, welcome back. As part of the module 5, we were discussing about how do you process data incrementally, and in the previous video, so we have discussed the data process, how does it happens incrementally, and that was more specific to the autoloader. And in the autoloader, if you are not seen the previous video, so I would just recommend you to please go and check the previous video in the same playlist. So where we have explained the concept of incremental data processing with respect to autoloader, so where it is very specific to loading the cloud files, like maybe the data files which are available in the cloud file system, right? However, so in this video we will discuss loading data from any different kind of sources, right? Especially it might be a IoT event hub, or it might be a event hub, or it might be a Kafka, or it might be just a file, or it might be a table which is getting updated automatically in the Databricks Delta table. So it can be any like it can be a CSV file location where the new files are getting added, or updated. So that's how exactly we want to show you in this demo. So how this incremental data updates can be captured with any kind of source systems or input types here. So before proceeding, if you are new to this channel and haven't yet subscribed to the channel, we would recommend you to please subscribe and also press bell button for instant notification. So let's get started. So when we talk about incremental data processing, any format, so these are the topics that we'll be covering as part of our demo. So we will see some theoretical part of it, because this video will be both the theoretical and practical, because there is some theory need to understand before we go to the practical aspect of it, because this theory is a little bit important to understand, so that then only we'll be able to clear your concepts. So we will go a few theoretical concepts like reasoning about why we are performing this incremental data updates here. So basically, what is the need of performing incremental data processing, right? So we have a ETL where we can directly pull the data from source system. We can schedule the pipelines, and it is all done, right? But what is the reasoning behind the incremental data that processing that we want to do here? And like treating infinite data as a table, so that means the data might be coming as an infinite infinitely it is getting updated in the source system, and that we are writing it to a table. So how it looks, okay, and what is the concept behind all this, the architectural thing, right? How exactly the programmatically or the architecturally it is processing inside, so that it also makes sense to us to understand the concept behind, so that our concept will be clear in end-to-end understanding this. Also, we will see something about end-to-end fault tolerance, because we are talking about streaming data here. And when we're talking about streaming data, so data also become quite important. So we should not lose any data in between. That is when we are copying from the source system or target system, or whenever the data is getting transferred from one location to another location, right? And finally, we will see how can we read, write, and persist the stream, because everything is stream. Once we start reading the data and writing the data, so everything will become a streaming read and streaming write, and also how do you persist the stream. So all this concept also we will discuss in this video. So before any without any delay, we will get started. So as we are discussing, so we will discuss the theoretical aspect of it first, and understand why we are doing the incremental data, and why there is a concept of incremental data load. So as you know, you can perform any kind of ETL operations or ELT operation, where you schedule your data pipelines to pull the data from a source system, and you maintain some kind of a watermark value. It might be ID value or timestamp value. Based on that ID or timestamp value, you perform an incremental data load. However, so there is a glitch around it, right? So there is a performance. We need to always keep log of that metadata. So where till what the data you have loaded, and again So you have to capturing that or maintaining that or performing that calculation around the change data capture is a little complicated, or it is a multi-step approach, and every programmer or a developer has to kind of explicitly maintain these control tables and explicitly mention all these codes in his data pipelines to maintain, to perform the incremental loads. So however, when you take examples like data scientists need to identify the data version, access frequently updated records in the operational database, or you want to check the credit card transaction need to be compared to the past customer behavior to identify and the flag records. So basically incremental data, it actually maintains the entire history of the data, so that you can compare the user behavior or the customer behavior compared to the previous versions, or compared to the previous data that we have. And also if you take example of a retail industry where a customer where you want to recommend a product to a customer using his purchase history, even in that case, so this use case can be used, and there might be a plain log files getting from the any distributed servers or systems need to be analyzed to detect and respond its instabilities. So even in that case, the data will be captured, should be captured in an incremental way. And there might be a clickstream data in the web application where millions of online shoppers are actually our customers are using it, right, and leveraged using A/B testing for user design, right. So basically in all these scenarios, the data is getting continuously generated. So that is very important here. If you see in all these use cases, the data is getting continuously generated and it has to be captured continuously as well. So that is the main need of it. And other thing is the volume of the data that is coming here is really huge data. So that is what we call as a big data, right. And so these are the scenarios, right. And in this so this is a need actually why there is a concept of incremental data load, so that we are talking in Databricks today, right. And Spark is already having a structured streaming concept which allowed to process the incremental data. So we can use Spark streaming as well here, right. And also we can use autoloader, that is a concept that we discussed in the previous video, which is specific for the cloud files. And what are the objectives? So objectives, definitely we will learn how the Spark streaming works here, and what are the different configurations options when we are doing this streaming, right, from the source system, and how do we maintain the end-to-end fault tolerance if there is any failures, how do we maintain that, and also what are the different options that we have when you are writing to the target system or the sink. So now let us understand, let us break these things and understand, right, so how exactly it works behind the scenes. So the magic behind the scenes happen using the Spark structured streaming concept. So how that it works is, take for example, this is a data stream, continuously the data is flowing in, and as you can see, the continuous in every seconds or in every microsecond there is a data that is getting generated. So this is nothing but it might be a single record or it might be a micro batch. Basically the Spark streaming, the structured streaming, how it works is it actually capture the micro event. So that means it is a batch, actually micro batch. It can have like 10-15 records or 20 records which has arrived in that particular batch, that is the times in that micro slot basically. So that will be captured continuously into the table. As you can see, this is an unbounded table. Unbounded table means that the table that continuously grows. There is no boundary for this table, right, because it is a streaming table. So why we are calling it as a streaming table? Because it is being written by the data stream, and it is continuously growing by time. And meanwhile this table grows, user can always interact with this table. It doesn't mean that this table will get locked or something like that. So meanwhile every second the data is being returned to this, user can also query, or there can be jobs that is getting data from this using queries. And it is an ever growing data source that we can call this table. And so that means whenever a new rows new data in the stream comes, so new rows appended to the unbounded table. Explaining the same graphic here, so the new JSON file is landing into the cloud storage, as you can see here. So whenever the new JSON file lands in that cloud storage, it automatically gets loaded and updates to the database captured in a CDC feed. And events is queued in a, so when it actually directly doesn't write directly to this unbounded table. In between there will be a pub or sub messaging feed, right? So where the data will be queued. Basically, if there is a huge amount of data is getting flowed in and it cannot be written continuously to the unbounded table, because so the particular micro batch or batch cannot handle that kind of data, so then it get queued and it get actually in a message queue. So that is, then we need to kind of wait for that queue to kind of clear it out, and then you will start getting the messages in real time. If there is a lot of data queued up, so you might not get the messages in real time because of that queue. So yeah, that's about and Spark streaming is optimized on Databricks to integrate closely with the Delta Lake and Autoloader. Basically, so what Databricks is doing here is it has optimized the Spark streaming here using the concept of Delta Lake and Autoloader. Basically, yeah, without this concept, what actually the organizations were doing so far is they were actually writing some logic. As you can see, many organizations have traditionally reprocessed. So there is two options, right? One is you can traditionally reprocess the entire data every time. Maybe it's a hourly schedule or daily schedule. You have to entirely refresh your source data every time. That's the approach number one. The other approach would be to write a custom logic to capture those files or records that have been added or updated in that time span. So yeah, so this will avoid these things, right? And you can directly configure it, and automatically the streaming job will take care of it. And now let us understand some basic concept, right? With some good example here. So as you can see, there is one good example where you can see there is a timeline here where you can take first second, second second, third second. So first second, if you can see, the data is being read into the input table. Basically, the new data comes into the input table, and then that is actually the source, right? So this is the source. So in the source, at the first second, there is only one record. You can consider like that. And the query is defined. Basically, if you see, query is nothing but it's defined against the input table. So this query is able to pull this input from the source, that is one record from the source, and write it to the result table. And finally, what will be happen to the output, right? So the output streaming pipeline will persist update to the results table by writing it to the sink. Finally, it is being returned to the sink here. So as you can see, the data in the source grows up. However, so you are not reading the result will not be the entire data set, right? If you can see the length of this, so it's always the same. It's always one record it is able to read, because it knows it has to read only the new data, not the complete data set. And here we are using a complete mode. So we will understand different modes are there. So complete mode is nothing but every time we are overwriting the result in the target table. So we will understand in a better way in a code below. But if it is a append, so then what will happen is the output will start growing similar to the input. If it is complete, that means it is overwriting the result. So that's why you see the same value everywhere. So let's jump to the fault tolerance concept. So when you say fault tolerance in the streaming system, you can imagine the different issues that might happen, right? So whenever the stream is running, the stream might get break because of some network issue, or because of some source table not available, or source table or the file might get crash or something for that matter, or the target table is not available, target sink is not available, right? So basically during that stages or during that issue happens, if there are, like, say, out of 1000 records, 800 records have been returned to the target table, but 200 records are pending still in the source table. So during that time, if the failure happens, right, and whenever you restart the stream, it actually, ideally, it should pick only the 200 left out records from the source instead of reprocessing entire 1000 records, isn't it? So that's what actually the fault tolerance of Spark streaming does here, using the concept of checkpointing. So checkpointing is nothing but here they are kind of storing the values of the metadata, right? So it actually stores the metadata information. So in a particular location, the checkpointing location, and then it will be able to kind of identify the point of failure, and only that it will be able to load the data from that point of failure. So basically, whenever the failure occurs, Spark streaming engine attempt to restart or reprocess the data automatically. Even though if that doesn't happen, if it fails, and there is actually a retry mechanism you can perform in the code itself. Even though if the retry also fails, then you can restart. User can manually restart. So even the restart happens, Spark streaming uses checkpointing and write ahead logs to record the offset. Basically, this is where it maintains the metadata of it, and then being processed during the trigger interval. So next, Spark streaming syncs as designed to be idempotent. So that is multiple writes of the same data, right, as identified by the offset, do not result in duplicates being returned to the stream. So that is very important here. So the duplicates issue will not happen here, and also the files will or the records will not get missed out, because the design is idempotent. So it will be able to capture based on the offset, right? And so this is how the end-to-end and exactly one semantics under any failure condition happens. So now let's start executing some code and understand it much better. So as you can see, reading stream. So reading stream, what is the syntax of reading stream in Spark is it is spark.readStream. The method will returns a data stream reader. So this is actually the method, and the return type of the method will be data stream reader, right? And this is used to configure and query the stream. In this in the previous lessons, we have already seen how the incrementally data loaded in the autoloader concept, but here we will see how it works with the delta lake table. So the code uses the PySpark API here, and also named as bronze, and register the streaming temp table as this table name, right? And we have executed this code already now. And now let us try to run this query, right? So since we have already executed the above code, so as you can see, this code, what it was doing is it was reading from a table called bronze. So you can consider any table here. You can read from a table, or you can read from any API that the data is having, or you can read from log analytics. You can read from any stream for that matter, IoT hub or event hub. So here I am reading from a table which is a delta table, which is a streaming delta table, and I am reading it as a stream. So if you read a table as a stream, right, and write it to a temporary table or any table, so then the output will look like this. As you can see, the output will be continuously running select statement, and you can see how much data is coming in and how much data is being read and what is the batch details and all these details, right? So basically, since it is a streaming table, so we have read it as a stream and written into a temporary table as a stream. So everything has become a stream here now. So this was not there in case of autoloader, because autoloader, when it write to a table, it will not be a stream table, but here whenever we write to a table, so that table, when we are reading it using select star or something, so that also will be as a streaming output we will get here. So as you can see here, it says it is not supported. The reason here is because we are not using any aggregated function. We are not basically this is not supported. Order by is not supported here. We can still use order by if you are using the complete mode as a complete mode, because if you are using append mode, so the data will always be appending to the target system. In that case it is not possible because it will have performance issues. So as you know, so the data has been returned to the temporary tables, temporary views for that matter, right? But however, you want to persist the data in your storage system, right? So in that case, what you can definitely do is you can read that view and write into that, read that stream basically, right? So you're reading the stream, which is a table here in this case, and you are writing that to the again to some temporary table. Now let us understand a few important concepts. We have already discussed enough about the checkpointing, but as you can see, Databricks creates a checkpoint by storing the current state of your streaming job, right? And the checkpointing combines with ahead logs to allow terminated stream to be restarted and continue from the point of failure. And checkpoint also cannot be shared between the separate streams. The reason is it is having its own data catalog. It cannot be shared between two streams. So if you are reading a data from one stream, right, and so that stream has to be read in the job 1, say for example, right, and that job 1 will have a separate checkpoint, and there is a job 2 which is reading from the same input stream, but that will need to have a different checkpointing because both are independent streams. And other thing is the concept of checkpoint, the output modes, right? So this is important, where there are two output modes here. That is output dot mode, that is append. You can give output dot mode as complete. So by default it will be append. The reason is whenever the new data comes, it will be incrementally appended to the target system. However, if you give complete, the result table is recalculated each time, right? Write is triggered. So the target table is overwritten with each batch. That means if there are 1000 records coming in batch 1, right, and so that will be written to target system, and in the next batch if there are 10 new records coming in, right, so these 10 new records will overwrite all those 1000 records in the target system. So complete is not recommended in the usual scenarios unless you are consuming that data from the target system and you are persisting it somewhere else. Always or most commonly used will be append mode. And finally we will discuss something called as a trigger interval. So if you are not specifying anything, by default the processing time that will become 500 milliseconds. So these are the options with a trigger method, right? So if you don't have any trigger method, as you can see, it will be 500 milliseconds. If you give there is one more way of giving it as a fixed micro batches. That means you can mention processing time 2 minutes. That means every 2 minutes your micro batch will get executed or kicked off and check if there is a new data arrival. So this is also one of the good approach if you want to, because you will always you can keep there is a flexibility of changing this processing time as and when required. If there is a very less amount of data that is getting updated, you can give it in hours also, the processing time, right? So you can avoid the performance issues, anything like that. Or if it is frequently getting updated, you can give in minutes or seconds as well. And you can give the triggered, so this is fixed interval, right? You can give the triggered micro batch and the triggered micro batches basically. So triggered micro batch is nothing but trigger once equal to true. So in this case the query will execute a single micro batch to process all the available data and then stop on its own. So here there is no fixed micro batch, right? So this is one micro batch which execute a single micro batch to process all the available data at that particular time and then stop on its own, right? And so here it is not a stream. Basically you are not streaming it because it is getting stopped. So once the data is loaded, the entire it is one time load, right? So basically it's like just a batch. And the one more option is where you give trigger available equal to true. Available now equal to true. That means the query will execute multiple micro batches to process all the available data. So the difference between the third option and fourth option here is Third option, if there are 1 million records, all the 1 million records will be loaded in one shot to the target system. If you use a fourth option, that is available now equal to true, so it will load 1 million records into chunk of multiple batches, micro batches, and it load one by one. So however, if you want to use the streaming, so then you have to use, either you have to leave it blank or you have to use processing time equal to some minutes or seconds or hours, whatever is needed, right? And let us see the practical code of it, how exactly it looks like, right? So as you can see, the output mode we have used complete. That means every time a new stream comes in or any micro batch or batch comes in, so entire data will be overwritten in the target table. And since we have given available now equal to true, what that means is load entire data what is available in the multiple chunks, right? And then obviously it get terminated. So this is optional method anyway. So once the stream is complete, once the load is complete, it actually kind of terminates itself. So now let's go to the next option, which is most commonly used in terms of streaming when you consider streaming continuously, right? So as you can see, the only difference as you can see here is processing time. Previously we are not given trigger option processing time equal to 4. What we are given is trigger available now equal to true. So that's why it was not a streaming. However, now what we are giving is processing time equal to 4 seconds. That means every 4 seconds your stream is checking for the files in the source system, and it is considered as each batch, right? And writing it to the finally the target table, and we are using a complete mode here. And the same output we are trying to read here, and that gives you the output here, like whatever is being written. Hope you are able to understand the concept of incremental load actually using the Spark streaming here, and the concept of autoloader we have seen in the previous video. So just try to kind of practice using this both autoloader concept and also reading the file from streaming and writing it as a stream, and how do you what is the concept of checkpointing, and what is the concept of writing the data as a complete or writing the data as append, right? And what is the concept of option trigger. So we have a different option as a trigger, right? We can give the processing time, we can give option like micro batches where once equal to true and available equal to now, available now equal to true. So these options you can practice, and hope it was useful, and thanks for watching.